I think strength is very poor. It's okay. 36 people. So, hope you enjoyed the session yesterday's. And today we're just discussing about IoT. So, as you all know, I'm Danan from final year of Computer Science and Engineering. So, it's my privilege to address you all on behalf of Aditya Engineering Institute of Technology. So, I would like to welcome all the participants in the workshop. We are truly delighted with your presence. So, for the purpose of conducting this workshop is to provide an every bit of information about Hackathon, and you will be getting an idea about how you can make a proper contribution into it. So, for this event, I would like to welcome Mr. Nishanth, our alumni from Rakuten India and full stack developer. So, I would like to welcome you on behalf of all participants. Welcome, Nishanth.
Thank you.
So, we are good to go. You can just give a bit of introduction and you can just start it.
Yeah, sure. So, hello everyone. I'm Nishanth. So, some of you might have already known me before, and I might not know most of you. So, I'm an alumni of AID Chikmagalur. So, I've studied in electronics and communication, and right now I'm working as a full stack developer in Rakuten, India. So that's a short brief about me. So before we start, so just wanted to have a chat with you guys to understand like how was your hackathon, and if somebody would want to discuss about what you did in the hackathon, and maybe just give a brief about how was your day. So anyone would be willing to do that?
So, guys, this is your chance. You can ask anything, any doubts and any queries. So, Nishanth can clear it out. So, before starting the session, without proper communication, we can't do anything, guys. Just try to communicate a lot. So, the communication is more important than anything else. So, just try to communicate. So, if you are uncomfortable, it's okay. You can just ping it on your messages in the chat box. You can just read it out. Yeah, we have a
Okay.
question.
We have a question here. Yes. What is a hackathon? Okay. So, what is a hackathon, right? So, in simple words, so it's, to put it in a very simple, plain way, it's a kind of a place where engineers get together, have an idea, and build a product based on that. Okay. It not need not necessarily be an entire product. It might be just a part of a product. So, let's take a very simple example, right? So let's think of a problem that we face on a day-to-day basis. So you guys attend college every day, right? And every day your lecturer would have to take your attendance. So is there a simple way to do this, right? Although there is a digital way right now where your lecturer might open an app and get your attendance on the phone. So is there a much more simpler way to do this, right, where the effort required would be lesser? So in this scenario, so can you guys think of some solution, some innovative solution which might make this whole process even more simpler? Anybody who would want to suggest something? Please be interactive. The more interaction we have, the more we get to know about each other and understand about stuff. So anybody who would want to give something, some idea on that? So imagine we have this scenario where a lecturer needs to take the attendance of a student on his mobile phone one by one, his or her mobile phone one by one. So how can we make this process more simpler? So this is our problem statement, right? A problem statement is we want to make this entire process of taking attendance simpler. So do you guys have any ideas of how we can simplify it? Yeah, so I guess DHI right now you have is like an app where again the process is manual, right? The lecturer has to look at who has come and then easily, yeah, right. Biometric is one very good option. I see one message in the chat who says biometric. So that's a really good answer. So you record the biometrics of the students and you place it on the front of your college door. So as and when a student enters, they punch in their biometrics, and once the biometric is done, you will automatically have the attendance updated. So this reduces the overall effort required in the process. So this is a wonderful idea. So let's say you have this problem statement and you want to implement this in a hackathon. So what would you do in a hackathon, right? You would have a team of, like, say 4 or 5 members. You all sit together, brainstorm, come up with problems that exist in real day-to-day life, come up with some real-time problem, and then come up with a solution for that, and build something very simple or something very complex, whatever is possible. You build something which will solve that problem and make it easily solvable for the rest. So this is like the overall idea of a hackathon. So as someone suggested on the chat, biometric is a wonderful way of avoiding the hassle of a lecturer having to open the mobile, look at students. Sometimes there might be manual errors in having the attendance. So you will avoid all these cases by doing it through biometric. That's a wonderful idea. So now how do you want to implement this, right? So how would you implement a biometric attendance system? So what are the components required for a biometric attendance system? So let's break it up into simple steps. So for a biometric authentication, first thing that you would need is something to either scan your fingerprints or to scan your eyeballs, right? You can do retina scan as well. So that is one thing, or you can do it through fingerprints. So these are the two ways through which you can perform a biometric authentication. There is also face recognition, but yeah, that is also one option as well. So say you want to do something which is related to this. So now the main component that you will need is a fingerprint scanner. And so since we are doing something related to IoT, let's connect this to IoT. So you have a fingerprint sensor which, takes the input from a student on the fingerprint. It records a fingerprint and consider this to be an internet of things. So we will understand what is internet of things later in our presentation, but for now consider this to be a thing which is connected to internet. So this biometric sensor, as soon as it scans the fingerprint, is connected to a microcontroller or a microprocessor, which is capable of sending this information over the internet, right? This is capable of sending the information over the internet, and you have a storage or a database where you store these details. So on a day-to-day basis, you will take the biometric of each and every student that enters the class, and you will record it in your database, and that would be your attendance database. So this is how you would solve this entire problem. So in a hackathon, you would do this exact same thing, but something that is related to the theme of your hackathon, right? The hackathon might be based on, the theme might be based, sometimes it might be based on only coding. Sometimes you might have hackathons where they would allow certain intervention of electronic components. So somewhere, if you want to connect this with IoT, you can do something like this where you can connect your coding knowledge as well as something which is related to a little bit of electronics in order to put it together, and this is what is internet of things. So that was one thing. Okay, so any other ideas do you guys want to discuss about? Feel free to unmute yourselves and talk. It would be good to know you guys. And I'm just a senior from your college, so feel free to talk. Anybody?
Yes, anyone at least. Just try to ping your messages in the chat box at least.
Yeah, even messages as well. Anyone? Okay, I think we can start with the actual presentation then, and let me
Yeah,
share my screen.
yeah, sure.
Yeah. Is my screen visible?
Yeah, yeah, Nishanth.
Yeah. Okay. So, like we discussed till now, so what is Internet of Things, right? So we will be discussing the basic foundation knowledge that you would be required in order to know about what is Internet of Things. How could you start with doing something with respect to Internet of Things? What are the use cases which is already in use, which implements Internet of Things? We'll be covering a lot of these kinds of stuff right from the basic. We'll be touching each and every topic in order to get you into understanding everything that is there to know about Internet of Things. So Before we start, just another thing, just another time I'm repeating this. As much as you guys are able to interact, I think it'll be better so that you get to know the proper intent of what we have in this entire presentation. So if right now anybody wants to come up and have a, if you want to give your own definition of internet of things, you're most welcome. If you want to unmute yourself, you can unmute and talk, otherwise you can ping on the group, on the messages. So we'll just wait for 10 seconds. If there's no messages, we will start with the presentation. Anybody?
Just try to communicate, guys. It's your choice.
Okay,
No one. Yeah.
let's
Yeah.
let's start. Let's get started. Okay, so let's begin with what we have for the agenda today. So we have initially we'll be looking at what is IoT, the basic introduction of IoT. Give me a second. Let me just connect my charger. Yeah. Sorry for that. So we'll be looking at what is Internet of Things, the basic knowledge about Internet of Things, what is Internet, what is cloud, what is IoT, everything. And next we'll be looking at something called the four pillars of IoT, which are like the main components which build up the IoT ecosystem. Then we'll be looking at few characteristics of IoT, some use cases, and a case study about FastTag, which is something which has been implemented using IoT. And later on, we'll be looking at some advantages and disadvantages of IoT. And at the last, we'll be looking at how you can start with IoT, how you can set up your own environment for building some basic applications and getting a brief knowledge about how you can work with IoT. So this is the major plan for the talk today. So let's proceed. Feel free to stop me anywhere if you have any doubts. I'll be happy to address them. So, okay, before we start, the basic understanding that we need to have about IoT is that what is internet? So, what is internet? So, anybody would like to answer this question? Either unmute yourselves or on the chat. Anyone? Any answer? Any basic answer that you know about what is internet? Anybody?
Connection of various networks.
Great, that's nice. Connection of various networks. That's a very good definition. Anybody else? Anyone else who has a definition, who has an understanding of what is internet in your own words? Anything that is anything, whatever you feel is internet. Anybody would like to answer? Okay. So, what is internet? So, internet is basically a vast network that connects devices and whatnot throughout the world. So, it's a very huge network. So, there's interconnection of devices between each other. So, this is, in very simple terms, internet is this. So, what is the main purpose of having these devices interconnected with each other, right? So, the main purpose is that they can communicate with each other. So anything that you take in today's example, so you have Instagram, you have Facebook, you have WhatsApp, Telegram, so many social apps, so many social media apps, Twitter. So how do these all work? So everything work over the internet. And if you break down the components of any application, ultimately it is basically communicating from one computer or one device to another device. So for example, if you open Instagram or if you open Twitter, so you get your feed, right? How do you get your feed? So there is, your device makes the request to another device on the internet for the data that needs to be displayed on your screen. That device gets your data and sends it to your device, and you will be able to see your social media timeline on your phone. So ultimately, when you break down any single application that is on your phone or on your laptop or on your computer system, everything breaks down to something which is a simple link between two devices. So that is what is internet. So in an internet, so just like all of us have an Aadhaar card, right? All of us have an Aadhaar card, all of us have a DL, all of us have a voter ID. Everybody has their own unique ID. So no two IDs can be same. So nobody else can have the same Aadhaar number as I have, right? Unless it's a fake ID card. So no two people can have the same ID number, or no two people can have the same unique number that is given to a particular citizen of a country, right? That applies to any country. If you have a citizenship, you have a number which is linked to you, and that is unique to only you. So this is something which is prominent everywhere. So you have something which is unique associated to every single being on this planet, or something, in any case you have something very unique associated to every single thing on this earth, right? You have something which is unique. So in case of internet, when a particular device has to enter into an internet, has to enter into a network, so how is this device identified in the network? So how would the device know which device is trying to connect to my network, or who is this who is trying to connect to the network, right? For this we use something called as an IP address. So IP address is a simple address, that is a simple number kind of address, or an alphanumeric address that is given to each and every device that connects to the internet. Be it your cell phone, be it you have smart washing machines, refrigerators, you have Google Mini, Alexa. So all these devices, whichever interact with the internet, connect to the internet using an IP address, right? So IP address, we have two types of two versions of IP addresses now. We have IPv4 and IPv6. So IPv4 is a 32-bit numeric address. That is, it can consist of 32 bits in total, 8 bit for each number. So you can see an example of an IP address that is given 152.168.35.12. So this is an example of how an IP address could look. But in real life, so this every number in between the dots can run from 0 to 255. So the minimum IP address that can be assigned is 0.0.0.0.0, and the maximum is 255.255.255.255. If you convert this to binary, this would become a 32-bit numeric address where each number is a 8-bit number. So as you know, in binary, 8-bit number can go from 0 to 255. So this is how an IP address is constructed. And for when you calculate the total number of addresses that could be possible with this combination, it can allow for a possibility of up to 4 billion IP addresses. That's a really huge number. We might think that it's a very huge number, but in real, this number, we have already crossed this number, and right now we are falling short of IP addresses with IPv4. So in order to overcome this shortcoming, IPv6 was introduced, where IPv6 is a 128-bit alphanumeric address. So it's not just numeric, it's also including alphabet, so that you have more number of combinations that is possible in the IP address. So with IPv6, we have 340 trillion IP addresses. This is the number with, the number of IP addresses that can be allotted within IPv6. So it's very it's very probable that we would run out of IP addresses anytime soon. So this is a brief about what is internet and how a particular device on the internet is identified. So is this clear? Can we move on to the next slide? Anybody wants to ask anything about this? Feel free to unmute yourselves on or message on the chat.
Nishant, would you please care to explain me about IPv6 again?
Yeah. So IPv6 is basically just a, newer version of IPv6, right? But IPv6 is able to carry a number as well as alphabet along with it. So basically that improves the number of addresses that you can use. So you can use 0 to 880000 to 9999, and as well as AAA to ZZZZ, as well as intercombination between these. So because of this, you have such a huge number of addresses that can be calculated or that can be prepared using IPv6. Does that answer your question?
Yes, thank you.
Yeah. Okay. So let's move on to the next one. Okay. So next we will look at the buzzword cloud. So how many of you know what is cloud? How many of you know what is cloud, or how many of you use cloud on a day-to-day basis? Anybody? Come on, guys. Like at least on the chats. Anyone? Yeah, I see a raised hand. Sarfaraz Ahmed. Yeah, would you like to unmute? You guys can go ahead and unmute and talk.
Yeah, if you're uncomfortable, you can just ping your messages in the chat box.
Anyone? Okay. So, what is cloud, right? Cloud is basically, it is a server which is accessible over the internet. So, what is a server? A server is nothing but a simple computer. So, okay, I see an answer which says virtual storage, right? It's virtual storage is a little bit different from cloud, but yeah, falls under the same category. So, cloud is basically essentially a computer system that is accessible to you over the internet. You can use this particular cloud system to perform various activities, right? You can host an application on that cloud system, or you can store data on that system. You can use it as a backup server where you would back up all your data time to time. So once there is a simple tool that all of us use, which is called Google Drive, right? Every one of you might have used Google Drive. Every one of you would have Google Drive on your phones. So what is Google Drive? So Google Drive is essentially a software as a service which is provided by Google, which allows you to connect to their servers to store your data on their servers, and they make it available for you without you having to take the headache of maintaining that server, maintaining the infrastructure, maintaining backups. Everything is taken care by Google, where you only need to probably pay a subscription fee. So you have 15 GB of free storage, and if you want to extend that, you would have to pay a subscription fees, and based on that you would be allocated certain amount of storage. So in the backend, what they do is they take your data, put it on a server, make it accessible to you whenever you need it. All this is taken care by the vendor itself. So you don't have to worry about anything that goes on in the backend. This is called as software as a service. So you are using the software through which you access the infrastructure, through which you access the data stored on your vendor. So a simple example for cloud is basically Google Drive. So what other things can we do on the cloud? So there is a lot of multimedia. So right now the major usage that takes place on cloud is the multimedia. So be it like Netflix, or you have Amazon Prime, or any OTT platform, right? That's These are huge amounts of data. So when you want to see a movie in HD, the movie would itself be around 4 GB to 5 GB, and they need to have the infrastructure to store it, and as well as simultaneously allow consumption of this media by a number of users. So this is where again it's a software as a service, where you don't have to worry about what happens on the back end, right? So you can just use it. So software as a service, along with it there's another thing called as platform as a service. These two fall very close to each other. We'll not be going into the depth of PAS and SAS, but for a brief understanding, this is what it means, right? So basically, cloud in short again refers to the servers that are accessible over the internet. So and you can see the last point that's mentioned there. Consumers can treat computing as a utility, leaving the technicality to be managed by the cloud provider, right? So there is I don't know if you guys have used, there is a simple online tool called as Playground OpenAI. Anybody who has used it? Anybody? Open API Playground, or something called as Wally. Anybody? Dolly, Wally. Anyone? So these are some AI tools which is provided on the internet for you, right? So you can basically, so for example, Playground Open API, what you can do is type a sentence. Say you will type, write a letter to my lecturer that I won't be attending college for 1 week. This is a single sentence, right? You give the sentence as an input, and it will write a letter for you and give you the entire letter. So how does this happen? This is again an AI system which you don't need to know the technicality about. As a consumer, what you want is you provide a problem statement and it gives you a solution, right? This is covered, and you don't need to worry about what is happening in the back end. How is the AI deciding what to write in your letter? All these things are left to the vendor to be handled. So when I say a consumer can treat the computing as a utility, leaving the technicality to be managed by the provider, it means that you just have to provide the problem statement, you get the solution, right? Everything that happens in between that is taken care by the provider. The cloud provider takes care of everything that happens in between. So there are many tools over the internet which provide these kinds of computing. Cloud computing simply means instead of just storing your data, they are doing some computations on your data and providing you an output, right? So you can find a lot of tools over the internet which have these kinds of abilities. So let's proceed further. So next we have, what is IoT? So this is our actual introduction to the topic of what is IoT, right? IoT is basically a network of devices which are capable of being assigned an IP address and can connect to the internet, right? So for example, let's take the example of Google Mini or Alexa, right? So these are devices, right? And these are called smart devices. Why are they called smart devices? One is because to a certain extent they are capable of computing your data and making a decision based on your data. That is one. And another reason is that these can connect to the internet and interact with their vendors in order to get information for us, right? So this is basically a device which is able to connect to the internet and give you some data, some meaningful information, right? So this is something which is a thing, right? It is basically a thing that is connected to the internet. So this is one example for a simple internet of thing. So next you have these whatever. So we can see that these would contain some sort of electronics, some sort of sensors which can interact with the external environment. So for example, if we took the example of Google Mini or Amazon Alexa, right? So it is able to take data, take input from you that is external to the device, right? It is able to take input from you and process certain information that given by you and return to you some meaningful information that would help you with whatever you have asked for, right? This is something which happens on the cloud. And then, so right now at this given point of time, there are 9 billion plus physical objects or things that are currently connected to the internet. And this is again an approximate number, and this number is expected to rise to almost 20 billion plus. So you can imagine the kind of demand that is there for IoT and the kind of development that is ongoing in this particular field, right? Let's proceed further. Yeah. So we understood about the definitions, we understood about what is internet, what is IoT, everything. So now let's come to the main question, why IoT, right? So the main simple answer is that it helps us, make our life easier and smarter. So you have Google Mini, you're lazy to type, open Google and search on Google. You are lazy to do that, then you just ask the Google Mini and it will give you the solution, right? You're very lazy to open Amazon, find a product and shop for it. You ask Amazon Alexa, it instantly order for you and it will be delivered to your house. So it, by a very large amount, it makes your life simple, right? And automation at large scale, right? So you can implement a lot of automation solutions using Internet of Things. So simple thing might be automatically your room lights might turn on as soon as you enter the room, right? You might have some kind of sensor which will detect. So you might have an IR sensor, you might have a heat sensor, any sensor which could detect a human presence in the room and automatically turn on the lights. And once you are out of the room, automatically turn off the lights. Right, this is something which can be automated at a small scale. Similarly, at a large scale as well, these can be implemented, like in manufacturing industries, where certain instruments which can certain large equipments can be controlled with certain stimulus, which can help you automate the process in a very large scale. So along with that, it provides IoT provides a real-time data and insights on the system. So for example, initially we discussed about biometric authentication system for your college attendance, right? So it provides real-time data and insights. So as and when a student punches in, as and when a student punches out, so you have data of the entry time, the exit time of the student. This is real time. And at any given point of time, you have the data about how many students are present in a particular classroom, right? This is something which is very beneficial. You get real-time data and insights into what is going on with your system, and it acts as a bridge to connect with the external stimuli. Again, like I said, it is able to communicate or perform and do an action, make a connection with the user and the internet, acting as a bridge in between. And it helps in creating ecosystem of connected devices. So if you have heard of Google Nest Hub, or if you have heard of Amazon Hubs, so these are basically smart devices which connect to the similar version of those devices. So a Google Nest Hub can connect to many Nest Minis in your house, and you can automate everything inside your home. You can automate everything, right from turning on lights, turning off lights, changing the color of lights, controlling your fan, controlling your ACs, turning on your fridge, reducing the temperature on your fridge. Everything can be controlled just by using a single device, which in turn interacts with multiple devices. So this is something which is called as an ecosystem. So you might have heard of people getting into the Apple ecosystem, getting into the Android ecosystem. You might have heard these terms very frequently, but what do these mean is, you for example, if a person is getting into the Apple ecosystem, it would mean that he has at least 2 or 3 Apple devices which can connect with each other, interact with each other, in order to provide you some meaningful input or meaningful output. So this is what we mean by an ecosystem. So this pretty much covers what we needed to talk about for the introduction of IoT. So anybody has any doubts or you want to ask anything, please feel free to ask. You can either unmute yourselves or you can ping on the chat. Anyone? Okay, let's proceed further. So now coming down to the 4 pillars of IoT, right? So there are 4 pillars of IoT. One is low power embedded systems, cloud computing, availability of big data, and connectivity. So let's go through each one of these in brief. So what is a low power embedded system? So a low power embedded systems mean that it might be a microcontroller, a microprocessor, along with certain modules, which can consume very less energy but provide you very high performance, and it needs to be compact. So you can't have a biometric system and have a huge supercomputer beside it, right? You need to have it very compact. It just needs to be a small device which can fit in front of the college door, right? So it cannot be something very huge. That is also a very main it's a very huge criteria which would affect the usability of the device. So you need to have the device very compact. It needs to use very less energy, give you high performance, and the electronics used within it should be very compact, right? So a simple example would be something like an Arduino Mini, Arduino Uno. You have Raspberry Pi. You have other many chips that come in with with Wi-Fi built in as well. So you have something called as ES32, which comes with a Wi-Fi chip built in, which can right out of the box connect to the internet. So these kinds of devices, these kinds of microcontrollers, will give you a very easy way to manage your Internet of Things. This is with respect to low power embedded systems. So next, let's look at cloud computing. Like we discussed before, we discussed a lot about cloud computing. So Why cloud computing is required in IoT is because we need reliable storage for massive amounts of data generated by IoT devices, right? So the amount of data that is generated by IoT devices are really really huge. So just a simple example that we took in the beginning is the college attendance. So for one day you have say 650 or 40 classes in your college. The each class is attended by 50 or 40 students. For every day you will be producing almost up to 1500 to 2000 entries for the records, right? And this grows exponentially, right? This can have a lot of exponential growth. So you need to be capable enough to store these amounts of data on the cloud or anywhere else where you can serve it over the internet. So that is what is meant by the cloud computing. Then you need to have computing power for data processing. So the attendance system just does not get over on recording the entry and exit, right? You need to be able to calculate the overall attendance of the student. You need to be able to calculate how many days the student was absent, how many days the student was present, how many hours the student was in the college, how many hours was he within the classes. So all these kinds of data needs to be done, the processing needs to be done on the back end, on the server. So these kinds of computing power is always required in an IoT system where you'll be able to handle such complex calculations. And you also get in-depth insights into the system through the power of AI and analytics. So in short, analytics was basically you get all these details of the students, you will provide a certain report, like how many students were present, what is the percentage of attendance, all these kinds of stuff. And with AI you can also implement something where you can maybe predict who might be present to the class, who might be absent to the class. This is just a fun thing, but in real time scenarios you can use AI for a lot of important useful stuff. But yeah, this is something where you can probably think of where AI might be used. Let's move further. So the next big pillar of big pillar of IoT, sorry, so is availability of big data. So big data, again, like I said, you have huge amounts of data, and the availability of these data needs to be very, very quick. You need to be very quickly able to access this data at any given point of time, and you need to be able to anytime at any given point of time you should be able to modify this data or update this data. So handling this data is very, very important for IoT. Next, coming to connectivity. So connectivity is like a must and should thing for an IoT device. It needs to be able to connect to the network and connect to each and everything that is present on the particular network. So this concludes the four main pillars of IoT, right? Now, let's move on to a few of the characteristics of IoT. Connectivity. So connectivity is one major characteristics for IoT. You need to be able to seamlessly connect to any device, any server at a given instant of time within a very short period of time. You cannot expect the user to wait. So you cannot expect a student to come punch in the attendance and wait for 2 minutes until it records, right? It needs to be instantaneous. It needs to be close to instantaneous. Otherwise, it is not going to work in a real-time scenario. Next, coming to intelligence and identity. So whatever data is generated, so whatever you generate from your devices, you need to be able to extract useful information from it and make some sense to the data, right? A sensor will generate a lot of data. Biometric system will generate a lot of data of who entered what time, everything, right? You need to be able to make meaningful use of this data. If you're not going to make meaningful use of your data, it's of no use that you have so much data. So you need to have certain level of this processing intelligence and identity to the data. Identity is every data must be unique and every device must be unique, right? So that you can track each data, track each device to its roots whenever required. So this is one of the main characteristics of any given IoT device, right? Let's move further. So then we have the most important aspect of IoT, which is scalability. Scalability is something you might have heard very frequently. What is scalability? So imagine you design, so let's go back again to the same example of a biometric system, right? You designed it for one classroom, right? So now how will you be able to expand this setup to all the classrooms without having to incur a very huge cost, right? So it need not be. So basically, how the solution, the problem statement here would be, how would you implement the same setup for each classroom, right, in an intelligent manner, so that you're not going to end up spending more. So this is our problem statement, and our solution would be, instead of having each sensor connected to a microcontroller, you can collect all the sensors to one microcontroller, so that it can process the data provided by all the sensors, and then unified whatever data that you get in that, and you can send it to your server and store it in your database, right? This is one way of scaling. So in this scenario, our scalability is very good, right? You're having a separate sensor for each classroom is very easy when compared to having the entire setup for each classroom, right? So this means our solution is much more scalable. Scalable is with how much ease would you be able to replicate your setup into a different scenario without having to make more changes. So this same setup, you can take it and put it in another college, right? That doesn't matter. So as long as you put it in another college, everything is unique to that college. The college ID is unique, your college ID is unique. So the entire data set is again different. So this is something which gives you an idea about what is scalability. The ease with which you are able to replicate your setup in a given particular environment is called scalability. Next, coming to dynamic and self-adapting. So every IoT device needs to be able to dynamically adapt themselves to the environment around it, right? So for example, we have a camera, a CCTV camera, right? You use a CCTV camera because you want to record footage, and if it is not able to work in winter, if it is not able to work in the night, then it makes no sense to have a CCTV camera, right? Your main intention of having a CCTV camera is you want round the clock monitoring. Round the clock, it needs to be able to record every single thing that happens around it. So this is a simple example where that camera needs to be able to work in all given sets of environment. You can't be like it won't work in summer or it won't work in winter. This doesn't go well, right? So you might have have had a look at Xiaomi's web camera that they recently launched. So it is an IoT device. It connects to the Xiaomi mobile app, through which it is able to connect to the internet, give you some meaningful information, store the recordings, all these kinds of stuff, right? So these are basically come under the category or the characteristics of dynamic and self-adapting devices. So that covers our characteristics of IoT. So next we'll be taking a look at some of the use cases. So before we move ahead, anybody wants to ask anything, please feel free to unmute yourselves, ask. And if anyone is not able to unmute yourself and ask, please feel free to share it on the chat. We'll wait for 10 seconds and then we'll move on to the next topic.
How to connect the sensors with IoT, sir? It's my doubt.
Yeah. Yeah, see, sensors is not necessarily an IoT device on its own, right? So you have a sensor. Along with the sensor, you need to have something like a microcontroller or a microprocessor. So this microcontroller or microprocessor will be able to pick the data from sensor and make some meaningful output out of it, right? So everything. So you know that every data on the internet or every data, whatever is transmitted, is mostly in the form of binary. So whenever you use a sensor, it also provides output. So for example, let's take an example of a pressure sensor. So how does a pressure sensor measure the pressure? So based on the pressure that you have given, the pressure sensor outputs a particular number. It will give you, say, from 0 to 1024. So based on the scale of the number, you are able to calculate how much pressure was laid onto the sensor. So this data is captured by a microcontroller or a microprocessor, and this processor or controller will be able to connect to the internet with the help of a Wi-Fi module or something which is helping it to connect to the internet. So once it is connected to the internet, you can easily broadcast this data into the internet, consume that data, and make good sense of it. So that is the overall use case where you would have to use in order to get a sensor working with IoT. A sensor on its own cannot become an IoT device. Once it is paired with a microcontroller or a microprocessor, this entire setup becomes an IoT device. Does that answer your question?
Yes, sir. Thank you.
Yeah, thank you. Anybody else?
Nishant, we have a question in the chat box. Savitra Shenoy.
Yeah, yeah. So, okay, this is a very interesting question. So, difference between vertical and horizontal scalability. Okay, so vertical and horizontal scalability. Okay, it's not really related to IoT, but I will give you the answer to this question. So in scalability you can have two types of scalability, which is vertical and horizontal. So one type of scalability is there. So imagine that you have a system which is having one CPU and 4 GB of RAM. Okay, so now if you want to increase your performance of your system, what would you do? You would upgrade your RAM, right? You would upgrade your RAM to 8 GB. So now your system performance for in the memory aspect has doubled. So this is one type of scaling. Next, another type of scaling that you can do, which is, this is not a real time scenario, I'm just giving an example. Another type would be, you will have the system on demand. So whenever you need, you will consume the required amount of memory. So you need 5 GB of memory, you'll be getting 5 GB of memory. You need 8 GB of memory, you'll be getting 8 GB of memory. This is something which happens on demand. So this is one aspect of it. So coming to another aspect is, instead of using one system of one CPU and 4 GB RAM, you will end up using two systems of zero point 0.5 CPUs each and 4 GB RAM each. So these two systems run in parallel, right? This is something where the scalability is happening parallelly. So you're increasing the number of agents on your side. So this way, the scalability is much more suitable because you can use it on demand. So if you don't need two systems, if you don't need 4 GB of extra memory, just kill that system and your system is still intact. You just have one instance of your system running and your system is still intact. So this is the difference between vertical and horizontal scalability. Does that answer your question? Okay, I will take that as a yes. Let Okay, cool. Anyone else? You want to ask any questions, or we'll move on? Let's move to the next one. So now let us look at some use cases where you can actually use IoT.
Nishant, we have a question
Yeah,
in the chat box.
yeah. Can we build IoT device? What do we have to learn in order to learn to build? Yeah, definitely. You can definitely build an IoT device. We will cover this. What do we have to learn in order to build? We will cover this in the upcoming slides. I'll cover this. Okay, let's move on to the next topics. So let's look at a simple use case, right? So maybe this would answer your question. You can build something like this, actually, in order to perform the irrigation based on the soil moisture. So what is an automatic irrigation system, right? So irrigation is one of the major problems that our farmers have had for a long time, right? Because it is unpredictable. You don't know when the soil might get wet. You don't know when the soil is lack of moisture. You don't know when you have to irrigate. Sometimes you might over irrigate and that will kill the crops. Sometimes you might under irrigate and that might kill the crops. So a simple solution for this is, we have something called as a moisture sensor. A moisture sensor can detect the amount of moisture in your soil. So you can set up a particular threshold for this moisture sensor. Say if the moisture drops below 50% in the soil, automatically pump water into the fields until it reaches 80%. So basically these kinds of things can be done using IoT. So a simple setup. So to answer your question, how do we build an IoT device, right? So let's take this example. How would you actually build this? So you will get a moisture sensor, right? You can purchase a moisture sensor anywhere and from an electronic shop. Then you would purchase an Arduino, right? You can just to begin with, if you're a beginner, I would suggest you to go with Arduino because it's very simple and easy to learn. And you should know a little bit of C programming language or C++, which will give you a little bit kickstart in order to understand and play with Arduino. So an Arduino will have multiple pins on it, right? So it is basically able to connect to sensors through the pins and communicate with the sensor, get the data from the sensor, right? So you can write up a program to get the data from the sensor into your Arduino. So once you have the data, what you will do is, there is a Wi-Fi module which will come to your Arduino. So you can connect a Wi-Fi module to your Arduino, as well as you can connect a relay. So let's look at the relay part later. So what is a Wi-Fi module? Wi-Fi module is simply a device that allows your Arduino to connect to internet via your Wi-Fi, right? So it connects to Wi-Fi, and from there you can access the internet. So what you will do is, from the Arduino, then you will send the data through the Wi-Fi module to the internet, where you will have a cloud system. So you can use many different types of IoT setups that are readily available. So for example, AWS has something called as AWS IoT, right? They provide a free tier where you can freely set up certain IoT devices over the internet and use their cloud computing. So as I told you, cloud computing is a major part of IoT device, right? So Amazon provides you this cloud computing system where you can easily use it through your device, right? Once you are so you can get started with AWS IoT, or there is something called as Microsoft Azure IoT. So these kinds of things basically will give you the cloud computing part of it, right? So you will send the data, and now you have the data on the cloud. Now you can build a mobile application, you can build an Android app, or you can build a web application, you can build a simple website through which you can consume this data, show the data to the farmer, right? About what are the moisture levels, how is it varying throughout the day, what are the different types of moisture levels that have been observed throughout the day. These kinds of statistics you can provide to the farmer, and you can also provide controls to the farmer where he can turn on or turn off the or irrigation. That is a manual override, right? You don't sometimes there the moisture sensors might fail and he might have to manually switch it off, right? So these kinds of stuff you can provide on your application. So using that, now once you do something on the application, that is possible to come to the cloud again. And so cloud in this case, I'm meaning something like AWS IoT or Microsoft Azure IoT, and from there you can consume your data. This will be sent to Arduino. Now Arduino has a signal that it needs to turn off the irrigation pumps, right? So what it will do is it will use something like a relay. So what is a relay, right? A relay is some, you can imagine a relay to be a switch. So it can be used as a switch in order to turn on the water pumps and turn off the water pumps. That is a relay. So whenever it feels, so one is either there is a manual override given by the farmer through his app, or there is a moisture drop. So then what will the Arduino do is it will turn on the water pump until the moisture level raises to 80%. Once it reaches 80%, it will again send a signal to the relay to turn it off. So in a simple scenario, so if you want to build this device, what you can do is you can take an Arduino, you can take a moisture sensor, you can buy a relay, and then you can buy a Wi-Fi module to connect to the internet. Get started with AWS IoT. So using these components, right, using these many stuff, you can build a lot of other projects. So with having a relay, you can build a lot of automation projects, like a voice activated light, or darkness automatic, or darkness, which the light which turns on automatically based on the light around it. So these kinds of stuff you can build. You can build multiple stuff just with few sensors and a microcontroller. So in order to build an IoT device, what you have to learn is you would need to know the basics of C or C++. You would need to have access to a microcontroller like Arduino, Raspberry Pi, Banana Pi. There are a lot of other variations. So Arduino is best suitable for someone who is starting up it, right? And once you have that covered, then you can start exploring how to get the data from the sensor to your Arduino, all these kinds of stuff. So once you're through with this step, then you can focus on learning something called like AWS IoT, or you have Microsoft Azure IoT. These are the major players, right, where you can leverage their infrastructure in order to process your data. So once this much is done, then you can focus on creating an external application, something like an Android application, an iOS application, or a Windows application, or a web app, which can then also connect to the cloud and make sense of the data, as well as control your devices right from there. So that covers automatic irrigation system, and I think that also answers on how you can start towards building IoT devices. Is that clear? Can we move on? Okay, take that as an yes. Let- Let's move to the next slide. Now let's look at some real-time use case, right, which is actually implemented. So FastTag. So all of you might have been aware or might have seen FastTag, right? FastTag is something which comes with an RFID tag which is attached to your windscreen, and as soon as you pass through the toll gate, your bank account or your wallet is automatically debited of the toll amount, and you don't have to wait in queue, you don't have to interact with people, you don't have to wait for the queue or anything. You just pass through it and your details are scanned and automatically the payment is made, right? So this you might have seen in real life, right? So this is basically a simple implementation of IoT. So let's look into how the payments are processed. So we are short of time. Can we extend for maybe 5-10 minutes, Dana?
Yeah, Nishan, we can extend till 30 minutes also. It's not, it's your choice.
Okay, sure. Okay, let's go through very brief on how a FASTag system works, right? So let's look at the case study. So all these details, whatever I'm sharing right now from now on, is present on the NPCI official website. These are just taken from there, so you can read from there as well. So how does this system work? So you have a toll plaza system, you have an acquirer, and you have an issuer. So acquirer means the bank on the customer side. Issuer means the bank on the NETC side. So NETC is again a national electronic toll collection. This is a corporation which takes care of all these kinds of stuff. And in between, you have something called as an online switch and a mapper. So let's look at how this happens one by one, right? So the first step. So the first step is whenever you enter the toll plaza, right? So it sends a request to the acquiring bank. It sends a request to the acquiring bank to initiate a payment, right? You will tell the bank to initiate a payment. So I take my vehicle to the toll plaza. As soon as it recognizes the FASTag, the details of the vehicle are captured. And then what it does is it sends a request to the bank. So whichever bank account you have linked with FASTag, will send a request to that bank that this person has entered the toll and will need to debit this certain amount for the toll fees, right? Now, what does the acquiring bank does? So the acquiring bank, once it gets the request, it will send this request to something called as an NETC mapper. So NETC, again, this electronic toll collection system, this corporation handles something called as mapper, which validates your tag details. So it needs to validate it is on the right vehicle, it is connected to the right bank, and the payment is being done once, not twice. These kinds of stuff is being taken care in between by NETC. All right, let's move. Now, once the data is validated, right? The data is validated by NETC. After that, it will produce a validation, right? A validation token is produced, and then it will initiate a request for the NETC system in order to debit the appropriate toll fare, right? So how much it calculates, what is the toll fare that is required based on the type of your vehicle. All these parameters are taken into consideration, and it initiates a debit request to the NETC system. So NETC system is the heart of the whole system. So that controls everything that goes on within the system. So now once the debit request is made to the NETC servers, what happens is it again sends this particular debit request according to what bank the user is using. The user might be connected to Axis Bank, he might be connected to HDFC Bank. So based on that, it needs to send the respective bank the request to debit your account, right? And once that is done, the bank initiates a debit request on its system, and it will debit the amount from your account. And once that account is debited from that amount, this again sends back the data to NETC that this particular transaction took place. And then once that is done, NETC is notified, and then the NETC will again open your toll plaza in order to let your vehicle through. So this is like the overall view of how a FASTag system works, right? So in FASTag, so what are the transaction flows? These were the flows that I explained. So you have an acquirer bank, you have an issuer bank. So acquirer bank is like the toll plaza's bank account, and issuer bank is the bank account that is connected to your FASTag. So in between, you have the NETC system, which will take care of everything that happens in between, like identifying what is the toll amount, identifying which bank account it is connected to, then settling the transaction, having the funds settled. All these is taken care by the NETC system. And this is like the overall flow that happens within a FASTag system. So is this clear? This is something like, this is an IoT real-time implementation of IoT, and it is being used not worldwide, sorry, it is being used everywhere in India right now in all the tolls. And you might have seen the amount of time it has reduced, amount of waiting time it has reduced in the toll gates, because everything happens instantly. The vehicle enters, the RFID scans, and then the payment is done, and then you're through the toll. So these kinds of things are simple solutions, like just like how we discussed about maybe the attendance thing. So it's a very simple thing, right? But if you implement it, the impact it has is very huge. The impact that it produces, the solution, the ease of which can be, the solution can be carried out is very, very huge. Brings a drastic improvement on the quality of the system. So this is about FASTag. So any doubts regarding this, or can we move on? I'll just cover the rest of the slides very quickly. Okay, let's move. So coming finally to advantages and disadvantages of IoT. So advantages is you can access the information anytime, anywhere, on any device. This is also a disadvantage because it can result in a breach of confidential information. Then you also have real-time access to data. You get good insights into the system and the communication between the devices, and you can automate the tasks which will reduce the human effort. Disadvantages is that if the data is not handled properly, then it is a lot of problems, because again, if it causes a data breach, then you are in trouble. And one more thing along with this is the data is ever increasing. The data keeps increasing, right? The data does not any time reduce in an IoT system. So you need to be able to handle this particular increase in data. This increase is exponential, right? And then you have, so in certain cases, if you have some bug on the system, any IoT device connected to the entire system will be affected by the same bug. So this is again a very major disadvantage. And also a disadvantage is that very rare cases you have interconnectivity between devices from different manufacturers. So again, the simple example of Google Mini and Alexa, you cannot make the two interact. Although you can make it interact by just having it side by side, that's a different thing. But internally, you cannot have these two communicate with each other. This is a major drawback, because this happens basically because there is no standards maintained, and every different manufacturer builds their devices differently. So if there is a certain universal standard on which a device is built, that would give you a lot of insight into how you can merge all these devices into a single network. That's about the disadvantages and advantages. Now coming to the hot topic for the day, how you can set up an environment for basic IoT applications. So I think we discussed this already. So you have cloud platforms like AWS IoT or Microsoft Azure IoT. So I would suggest you guys, if you are starting out now, try out AWS IoT rather than Microsoft Azure, because Microsoft Azure is a little complex when compared to AWS IoT. So with just the basic knowledge of C, and you have few sensors and microcontroller, you'll be able to right away build an IoT system and get through it. You have a lot of tutorials on the internet. You can find a lot of stuff on the internet. At any point of time you have any doubts, Google it out. You will have a lot of answers to these questions, right? So this is about the process of how you would have to start up. So to remember, you will need a proper microcontroller, a sensor that you would need in order to use for your use case, and then AWS IoT or Microsoft Azure IoT for your cloud computing tasks, right? Let's move to the next. So you would also need the hardware, like we discussed. You would need an Arduino, for example. So why we chose Arduino is because it's very simple to learn as a beginner. So you have a lot of variations in Arduino as well. You have Arduino Uno, Nano, Leonardo, Mega, many types of variations. To start with, you can go with Arduino Uno, because every single tutorial you'll find on the internet is based on Arduino Uno, and you will be able to get through it very easily. And these are like so shifting between different Arduinos are not difficult though. It's basically just the difference in processing speed, processing power, and the number of pins on the microcontroller. So this is with respect to Arduino. So the advantages of Arduino is that it's very inexpensive. You get it around 100 to 200, 300 rupees. You get a good Arduino, and you will be able to easily flash different programs to it, rewrite every time, make a different program. It's very easy and compact, easy to learn for it, right? So there's not much that can go wrong if you want to try it out. So this is with respect to Arduino. Another option might be something like Raspberry Pi. So Raspberry Pi, I would not recommend you to start with because it's something which is, it's like a mini computer, like it's a single chip computer, right? So with Raspberry Pi, you can not only do something like an IoT application, but you can also set up a server on it. You can have a server running on the Raspberry Pi. So for a simple example, on at my home, I have configured a Raspberry Pi to run as a media server. So what does this media server do? So I have an external hard disk connected to this Raspberry Pi, and from any device in my house, I'm able to access this Raspberry Pi and get data. So it's like my personal Google Drive, right? You get the whole idea. So I don't have to rely on something external. So I have a hard disk which has all my data, and at any given point of time, as soon as I connect to my Wi-Fi network, I also have access to my Raspberry Pi, which I can just access. So if I want to watch a movie, I can directly stream it out from my Raspberry Pi. I wouldn't even have to have it on my phone. So these are some things which can also be done with Raspberry Pi. It is not just for IoT. You can use it for a lot of other purposes. It's also like a single chip computer. So I would say if you are a beginner, this could kind of be overwhelming for you. So you could better start with Arduino, and slowly once you progress, you can move towards Raspberry Pi. So this is overall about IoT. What are the characteristics, the major components, how you can start with. This was like the entire brief overview of IoT. So as a if you again have any doubts, please feel free to unmute yourself and ask. Otherwise, you can also ping on the group chat. We will be able to answer those questions and talk about it. The more you interact, the more you will have a good understanding about what you need to know, right? So now we will move on to again a very last, this is going to be the last topic for the day. So next, there is also something beyond IoT. So IoT does not end here. So you have something called as Internet of Behaviors, right? So what is Internet of Behaviors? So you have lots of data collected from IoT, right? So you have a lot of data of the user which is connected to it, right? So you will be able to have access to a lot of data at once. So these kinds of data can give you a lot of insights into your customer. So about the behavior of the customer, about a lot of personal data of the customer. So these kinds of information are accessed by the system. And once you have access to these kinds of system, you'll be able to build products which serve your customers better. So for example, Netflix or Amazon Prime or any other OTT platform always have something called as a recommendation engine. So how does a recommendation engine works? There are various parameters by which they will measure your time that you have spent on your IoT, time that you have spent on your OTT platform. How much time have you looked at what type of content, what type of content have you liked, what type of content have you disliked, and how much time have you spent watching one type of show. So these kinds of information are very, it's actually a real personal information which they capture, and unfortunately we also allow them to capture those informations, and they use these kinds of information in order to perform, in order to provide you recommendations. So you have recommendation engines which will give you the proper suitable series. So for example, you finished watching a series, Netflix will give you a recommendation based on your previous history. It will give you a recommendation on which show you can watch, and you most probably will like the show that it would recommend, because it is based on, again, coming out from a very efficient AI algorithm. So these kinds of things. So this is something called as an Internet of Behaviors. Next, you have COVID-19 protocol violation tracking, right? So you can use RFID sensors in order to track your employees and all that. If you want to see if somebody is not wearing their masks, these kinds of things can be done. Then also, if you have seen Zomato or Swiggy nowadays also provide a temperature measurement of the employee. These kinds of stuff are everything automated, and it is real time data. So this is something which is an application of IoT. So again, what is with whenever we come across, there are many advantages. There are also a lot of challenges that comes along with it. So with IoT, again, the challenges is that this behavioral data can permit hackers to access a lot of sensitive information about your patterns, your daily patterns that you follow in your daily life. So these kinds of information are really personal, but unfortunately nowadays every single application has access to it. So any sort of data leaks, as long as the company is careful with your data, that is totally fine. But in case any data leak happens, it is going to be a disastrous situation, which is always, we have to accept the fact that with any technology advancement, there is also a challenge which comes up with it with respect to the data. So with this, I would like to wind up today's session. Okay, we have one question which is said about relay. What is the use of it? So a relay is basically a switch, right? So it provides isolation between the inputs and the outputs. Now your Arduino works on 3.3 volts or 5 volts, right? But your devices, electronic devices, whichever is a water pump or a computer or whatever it is, right, an electronic device, a light bulb or anything, works on 230 volts AC. Now you need your Arduino to be able to control that bulb or that washing machine or that fridge in order to turn it on and off, right? And you don't have 230 volts. Arduino is not capable of having 230 volts, right? So it only has 3.3 volts or 5 volts on your input pins and output pins. So when you connect the Arduino to the relay, you have another pin called as a signal pin. So you're connecting Arduino as the power source to the relay, and your signal pin is going to be high or low. So you get the idea of high or low, right? High or low is basically positive voltage or zero voltage. So whenever the Arduino provides a signal to this relay as a plus 5 volt, the relay automatically switches on the 230 volt system. So it acts as a switch which is isolated from the Arduino, but it is capable of controlling something which is of a lot higher of load. So it is able to just add or turn on and turn off that load on the other end without having your Arduino being affected from that voltage. So this is a relay. Relay is basically a component which provides isolation between two electric networks, and you can control one electric network from the other. So does that answer your question? Got it. Okay. So that is pretty much going to be it for today. Thank you guys for the opportunity. Thank you everyone for joining in and giving me the opportunity to conduct a talk on this. So I think that is going to be it for today. So if you want to get in touch with me, I'm always available. You can contact me via email, you can contact me via LinkedIn, and that is my blog website there. So if you guys want to check it out, feel free to have a look at it. So there is a lot of tutorials that I do on, this is mostly related to software engineering rather than IoT, but I also have a few tutorials on Raspberry Pi and other stuff. So feel free to check it out. Feel free to contact me if any of you guys need any help with anything, or you just want to have a talk. Feel free to hit me up. I'm available on email and LinkedIn. So yeah, that's going to be it for today. If you guys have any doubts or you want to ask anything, you want to have a chat, please feel free to unmute at least now and speak up, or else you can drop a message on your, yeah. What have you got to say for to the beginners? I mean, how can we start on IoT? Beginner friendly tips. Yeah, like I said, don't get overwhelmed with lot of stuff ongoing. Don't get overwhelmed with lot of stuff that you hear from outside. If you know the basics to C programming language, you have covered the major part of IoT, right? And once you know that, you need to get access to a microcontroller, purchase an Arduino Uno, purchase an Arduino Nano, anything that comes under your budget, purchase a simple sensor, right? It might be a simple relay again, where you can just control your switch, control your light bulb on and off. So this is a simple project where you can get started with, or you can just turn on an LED light as well. So you'll need an Arduino, you'll need a sensor, and then sensor can be of any type, whichever suits your particular need. And then finally, you will need to start learning a little bit about AWS IoT. So under the AWS free tier, you have access to a lot of their features, AWS IoT, which can help you with your, it provides you a simple UI where you can turn on your light, can send a signal from AWS to your IoT device to turn on the device, or you can also send a signal to turn off the device. So this is something which will give you the entire ecosystem of IoT. So that is basically the tips that I would suggest if you want to get started with IoT. Does that answer your question? Good. Okay. Any other questions, guys? Please feel free to unmute or drop a message on the chat.
So any question, guys, you can ask him. Okay, Nishant, I having one question. So
Yeah.
it's not an IoT part; it's in completely big data. So
Mm.
the big data means I think have it out in database.
Mm.
So like just come to the database part. We're having an SQL and no SQL, right? So
Mm.
in SQL, we having a schema and it's a relational database management system.
Right.
We'll just use it out for the complex websites, and we can just use the complex queries in SQL.
Mm.
Come to the NoSQL part. Take an example, MongoDB. Most of the reputed companies were just using a MongoDB. Take an Amazon and all. So my question is, what like how are you people going to handle those the complex queries in NoSQL part in MongoDB? This kind of
Yeah.
things.
That's a good question. That's a very good question. So, whenever you build a big data system, right? So, it's not necessary that your data has to be big data in order to use a NoSQL system, but you can use it. So, a NoSQL system basically the difference the difference between MySQL and the NoSQL system, right?
Yeah.
So, a SQL data system is basically a relational system where there's a lot of interconnection between the tables, blah blah blah. A lot of goes on, and you need to have a lot of complex stuff. So NoSQL is a simple thing. So you have no schema, no nothing. You store something called as a document. So if you have heard of JSON,
Yes.
everything in a NoSQL database is a JSON. So you store all the data as JSONs, and it is called a document in a NoSQL database. So the system is built in a way where you don't need to handle complex queries.
Okay.
Right. So in your regular, say for example, a traditional system which uses a SQL database, the system is built in a way where there is a lot of interdependency between the system. So for example, you have a simple application which lets a user log in, right? So in a traditional system, how that would be handled is once the user logs in, it will check via the OAuth server. There is something called as OAuth where it will check the authentication and then store your information to the database. Now you have an ID for the user. Now there are multiple tables where this particular user's data is stored and linked to this particular ID.
Okay. Okay.
This is a traditional SQL system. With a NoSQL system, every component is a microservice. Login is handled by a separate microservice. So login knows user ID is only connected to login. Now again, your data is handled. So for example, let's say it's a application like Instagram. So your photos, whatever you upload, it is handled by a separate microservice. It doesn't necessarily need to know about the user database. So user, it just communicates with the token to know that the particular user is valid or not. Based on that, then it will fetch the data only from the database which consists of the images.
Okay.
So with the same thing, if you have to achieve with the traditional system, you would actually have to perform joins. You
Join
would have to
operations.
create join. You would have to do a lot of join operation in order to identify which user is logged in, which user's data you need to serve, which image you need to serve. So all these things will be within a single query. So it will be slower. But with a NoSQL database, you don't need to have context or pretext of what is happening or what is not happening. Every service will be able to deliver its own data. So that way, your system is built in a way where it is less dependent on each other. That is why NoSQL and MySQL is such a big design choice when it comes to building huge systems. With big data, it is always advantageous to ultimately move towards NoSQL because NoSQL also offers you clustered scaling. So if you have heard of MariaDB, it offers something called as clusters,
Yeah.
which will help you in scaling. On-demand scaling is very good in NoSQL rather than SQL. So this is like the general overview of it. But if you want in detail, we can discuss sometime
Yeah.
later.
Sure. 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 Thank you. Thank you so much, Nishan.
Yeah. Yeah.
So, guys, if you have any questions, feel free to ask. It's your choice, and no one, at least any one. Any feedback, at least.
Yeah, sure. Any feedback, anyone? Okay, can you explain SaaS again? Yeah, SaaS is basically again software as a service, right? So simple example is Google Drive. So you are given the software. Google Drive is a software that you are given, and you just use the software. You don't need to have any background about what happens. Like you just upload your files into Google Drive. You don't want to know about how they store it, where they store it, how they handle the data, how are they taking the backup of the data. So once you store in Google Drive, you upload a file, you expect that file to be there for your lifetime, right? So but you don't have to worry about how they will take the backups. So in the backend, they need to take backups of your files. They need to make sure that it is always available to you. So all this headache is taken away from the head of the user. So the user only uses the software and pays for the software, and that is why it is called as software as a service. Is that clear your doubt?
Yes. Nishant, may I also know about PaaS?
Yeah, platform as a service is a little, again, kind of very similar to software as a service, right? So platform as a service is like you give a certain set of tools also to the user where he can make certain decision about how it works, right? Software as a service mean you don't have control about how things work on the back end. Platform as a service gives you a little more exposure towards that, although the on the higher level it is almost kind of, like very similar, I would say. But yeah, that is like the overall you know definition that is there for it.
Yeah, thank you. It clears my doubt.
Yeah. Anyone else?
Anyone, guys? At least just try to give a feedback. Anyone? We're expecting only one at least.
Thank you.
Yeah.
I'm glad it was
Sridevi.
informative. Thank you.
Thank you for your time in the session. Thank you, Mubarak. Thank you, Sridevi.
Thank you, guys.
So,
Yeah.
personally, Nishant, I just need to thank you a lot. Why? Because yesterday I just called you and you were just accepted in a second. So, thanks for that. So, it's been a great opportunity to host you as a guest. So, thank you.
Thank,
Okay. Samyama Patil, Savitra Shanoy. So, okay. Thank you, Savitra. Thank you, Samyama.
thank you, guys. Thank you very much.
So,
Yeah.
anyone? Any feedback? Why, Nishant?
Okay.
Just inform the participants to give a feedback, but I don't know why they are so silent.
It's okay. No worries.
Yeah.
Hey
Yeah.
Nishant, thank you
Hello.
so much for making time even on your day off and imparting such valuable insight and expertise on IoT. It was such a wonderful session. Thank you so much.
Thank you. I'm glad it was useful. Thank you so much.
Thank you. Okay, Nishant. This
Yeah.
for the session, and thank you, guys. Thank you for participating, and thanks a lot for everyone. Thank you.
Thank you. Thank you.
We'll
Bye
wind up
bye.
here. We'll wind up here.
Thank you.